Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson, which we are learning about molar solutions and, to be specific, concentration of a solution. Concentration of a solution. If you remember in the previous lesson, we were learning about molar solutions, and we said that a molar solution is a solution that contains 1 mole of a solute in 1 liter of a solution. It is a solution that contains 1 mole of a solute in 1 liter of a solution. And I gave you an example of sodium hydroxide. And I told you that a molar solution of sodium hydroxide would be prepared by dissolving 40 grams of sodium hydroxide in 1000 centimeters cubed or 1 dm cubed or 1 liter of water, of distilled water. That is how you prepare a molar solution of sodium hydroxide. Get the mass of 1 mole of a solute, then dissolve that mass of 1 mole of a solute in 1 liter of a solution. Then you now get 1 mole of, or a molar solution of sodium hydroxide. In this lesson, I want us now to focus on concentration of a solution. And I want to start by defining what is concentration of a solution. Then we see that concentration is the amount of a solute contained in a given volume of a solution. The amount of a solute contained in a given volume of a solution. Amount of a given solute contained in a given amount of a solution. That is what we call a concentration. For example, if we have 10.6 grams of, let's say, sodium carbonate dissolved in 200 centimeters cubed of water. That is the concentration. We have 10.6 grams of sodium carbonate dissolved in 200 centimeters cubed of distilled water. Therefore, the concentration of this solution, concentration will be this 10.6 grams per 200 centimeters cubed of distilled water. That is now the concentration of that solution. It is 10.6 grams of sodium carbonate dissolved in 200 centimeters cubed of distilled water. And that is the concentration, because concentration refers to the amount of a solute, amount of a given solute contained in a given amount of a solution. That is what concentration is all about. And therefore, At this time, I want us now to do some examples on concentration of a solution. Examples on concentration of a solution. That is the first example. It reads, suppose 4.0 grams of sodium hydroxide were dissolved in 400 centimeters cubed of distilled water, then made up to 500 centimeters cubed of solution. Then determine the concentration in grams, and second, the concentration in moles. That is a very good question. But before we move forward, I have to explain this to you. That when we are talking about 1 liter, when you're talking about 1 liter of water or 1 liter of distilled water, then this 1 liter must be accurate. This 1 liter must be very accurate. And for it to be very accurate, then you have now to use the apparatus for measuring accurate volumes. And in this case, the apparatus we are using is a volumetric flask. A volumetric flask. So volumetric flask is used to measure accurate volumes in the laboratory. Therefore, in this question, the question means that if you took 4.0 grams of sodium hydroxide, you dissolved it in 400 centimeters cubed of distilled water. You dissolved it in 400 centimeters cubed of distilled water. Then this solution, it's now a solution because of sodium hydroxide is a solute and the solvent is water. There is now a solution of 400 centimeters cubed. Then it has now been transferred into a volumetric flask whose volume is 500 centimeters cubed. 500 centimeters cubed. Then it has now been topped up to the 500 mark. Therefore, if this is the volumetric flask, I have now to remind you how the volumetric flask looks like. That is the volumetric flask we are talking about. So if you have made a solution of you have dissolved 4 grams of sodium hydroxide in this volume, then you now transfer the solution into this volumetric flask, and then you top up with distilled water up to this mark, because it is at this point when the volume of this volumetric flask is exactly 500 ml or 500 centimeters cubed volume. Therefore, in this question, then we are now to calculate the concentration in grams or concentration in moles. And therefore, concentration, if we are now to get the concentration, then concentration for uniformity purposes. For uniformity purposes, then we have now to convert it to 500, not 500, but 1 liter, 1 liter solution. Because now in this, 4.0 grams are dissolved in 500 centimeters cubed. They are dissolved in 500 centimeters cubed. Therefore, if it is now concentration in grams, then if you are now to make this volume 1 liter, then it would be 1 liter, and the amount of this solute is also going to rise. Therefore, it would be 8 grams per 1000 centimeters cubed. You have raised the volume. If you raise the volume, then you also raise the amount of the solute. Therefore, the concentration in grams is 800 per 1000 centimeters cubed of distilled water. That is now the concentration in grams. This is A. With B, it is now the concentration in moles. If you remember that moles, in the previous lessons, you see that moles are given by mass, you divide by the RFM, or the RMM, or the relative molecular mass. Therefore, the mass we have is 4 grams. It is 4.0 grams. You divide by the relative formula mass of sodium hydroxide. The RFM of sodium hydroxide, this is 23 plus 16 plus 1, then this gives you 40. That is the molar mass, or the RFM of sodium hydroxide. Therefore, moles are given by mass, which is 4.0 grams. You divide by the molar mass, which is 40, and this is now going to give you 0.1 mole. Therefore, it means that the concentration in moles is 0.1 per 1000 centimeters cubed, or 0.1 mole per liter. 0.1 mole per liter. That is how you go about those questions. And I hope that you've understood that so clearly. I want to repeat again that suppose 4.0 grams of sodium hydroxide were dissolved in 400 centimeters cubed of distilled water, then made up to 500 centimeters cubed of solution. Then determine the concentration in grams and in moles. We are saying that if you dissolve 4 grams of sodium hydroxide in 400 centimeters cubed, and that solution is now transferred to a volumetric flask, and the size is 500 centimeters cubed. This volumetric flask, then you now top up until it reaches this point exactly, because if it becomes more, then the concentration will go down. Therefore, you have now, it has to be exactly at this mark, because it is that at that mark when the volume is exactly 500 ml, or 500 centimeters cubed of solution. Therefore, that is now about the solution. We are now to calculate the concentration in grams. If 4 grams are in 500 centimeters cubed, because now grams are expressed, or concentration is expressed either in grams per liter or moles per liter. Concentration is expressed either in grams per liter or moles per liter. This is not a liter. This is 500 centimeters cubed. Therefore, if 4 grams are dissolved in 500 centimeters cubed, then how many centimeters cubed or how many grams will be dissolved in 1000 centimeters cubed? And that is now when we came up, or how we came up with 8 grams per 1000 centimeters cubed. Therefore, that is the concentration of sodium hydroxide, 4 grams in 500 centimeters cubed, or 8 grams in 1000 centimeters cubed. Now, in the second, the moles per liter, remember when we are calculating the number of moles, we're saying that moles are given by mass divided by molar mass, or the relative formula mass. The mass is 4 grams. It's the mass you are dissolving. The mass is 4 grams. The molar mass is 40. Therefore, this is, you get 0.1. Therefore, the concentration of that solution is 0.1 mole per liter or per 1000 centimeters cubed. And that is how you go about calculation of concentration. I want us to do one more example. That is the second example. The example is when 34.8 grams of potassium sulfate were dissolved in 500 centimeters cubed distilled water. Calculate the concentration of potassium sulfate in grams per liter. So calculate the concentration of potassium sulfate in grams per liter. Therefore, we have first to determine the RFM of potassium sulfate, and this is how we'll go about it. The RFM of potassium sulfate this is 39. That is the the relative atomic mass of potassium times 2 plus the mass of sulfur, which is 32, plus the mass of oxygen, which is 16, then times 4. Therefore, this is 39 times 2 is 78, plus 32, plus 64. Then this will be 78 plus 32 plus 64. That is 174. That is the RFM of potassium sulfate. Therefore, 34 grams, 34.8 grams are dissolved in 500 centimeters cubed. Then now, how many grams would be, or how many grams will dissolve in 1000 centimeters cubed? It is just a cross multiplication mathematics. This would be 1000 times 34.8 divided by 500. And you'll get that as is 69.6. 69.6 grams per 1,000 centimeters cubed. 69.6 grams per 1,000 centimeters cubed. That is the concentration in grams per liter. If we were to calculate the concentration in moles per liter, because we have said that concentration is expressed either in grams per liter or moles per liter. This is the concentration in grams per liter. If we were to calculate the concentration in moles per liter of the same question, then it would be, we have 34.8 concentration in moles per liter. The number of moles are given by mass divided by the molar mass. And therefore, the mass is 34.8 divided by the RFM, which is 174. Then this will give you 0.2 mole. 0.2 mole, that is the concentration. In 0.2 mole, that concentration is in 500 centimeters cubed. That concentration is in 500 centimeters cubed. And therefore, we'll just have to say that if 0.2 are contained, or 0.2 mole of potassium sulfate is contained in 500. Then now what about 1,000? Then what about 1,000? How many moles will be contained in 1,000? Therefore, this will be 1,000 multiplied by 0.2, you divide by 500, and this will be 0.4 mole per 1,000 centimeters cubed, which can also be written as 0.4 molar, just capital M, 0.4 molar. That is the concentration. Okay, 69.6 grams per 1,000 centimeters cubed. This is the concentration in grams per liter. While 0.4 mole per 1,000 centimeters cubed is the concentration in moles per liter. I hope you now get the difference between the two. One is concentration in grams per liter. The other one is concentration in moles per liter. I hope you now get the difference between the two. Then again, I have said that 0.4 mole per 1,000 centimeters cubed can also be 0.4 molar. Then ensure that M is a capital letter, not a small letter. That is the second example. I now want to leave you with this assignment. I want to give you one question for the assignment. Suppose 71 grams of sodium sulfate are dissolved in enough water, then made to 1 liter of solution, then determine the concentration of the solution formed. Ensure that you attempt that question before we meet in the next lesson. And again, in the next lesson, we'll be learning about the molarity of a solution. Therefore, let's meet in the next lesson.